And there's a little Ethernet / USB board. Isn't that nice? Like the quality of the PCB material there. It looks really schmick. Nice gold-plated card edge connector. And I've got an ST ARM micro for those playing along at home. And a Micrel jobby there, is it? And what else? An Altera something or other. That's a little FPGA or CPLD, is it? These are bloody self-tappers. Look at this. Unbelievable. Ha. Got it for nicks anyway. Yep, so we had to get that off to take the whole back panel off here. So self-tappers into there. That's a bit how you're doing. And then just two oddball self-tappers on the bottom. And it looks like, well, it was starting to slide. There we go. Oh, we're in like Flynn. Wow, look at that. Open chassis. Look. Look at the big ass toroidal transformer. Oh, beautiful. Thing of beauty is a joy forever. Of course, they haven't made the mistake of, shorting out that nut to the top. Yeah, it's not touching the top case, because then you'd get a shorted turn and that could ruin your day. Assuming that it's connected down to the bottom. Yeah, look at that. Oh, wow. Look how they've done that. Thoroughly interesting construction. Look, they've got this open frame. They've got this big ass heatsink. You can see the fins right in here, which goes from one side to the other. So one side has the fan on it. You can see the fan down there, and they're just like extracting it like that. That is fascinating. You've got to ask though, why make it this length? Okay, you've got to make it this big. You've got this big ass toroidal transformer here, which is beautiful. This is a 3-channel unit. Okay, so you've got the optional 3rd channel up here. You can see all the mounting holes for that. Like, could you shrunk the board a little bit more and got rid of and made it this long? Like maybe this long instead of that long? I don't know. Maybe they had some requirement to make it that length. That's just my feeling though, is that it could have been made a bit shorter. There's our relays, of course, for our tracking switching. You can see those down there. That's very nice. These boards are completely galvanically isolated from each other, but that's just gorgeous design and construction. I really love that. And they've actually put a metal on top here so that it didn't interrupt the airflow going through here, because you see how we had all those vent holes over here like this, which helps with the radiated heat, but of course you don't want your airflow to be interrupted. You want it to all come from your fan here and all go right over the fins of the heatsink. You don't want it buggering out in or out of these holes here. So yeah, you want to put that that top cover on there. That's nice. But there's a big relay over on the main section here. Oh, and look at the, hang on, look at the real clunking power switch with the rod going through. Ah, beautiful. Brings a tear to the eye. Check out the mains input board here. Look at that big EPCOS choke there. That would have cost a fortune, wouldn't it? That is beautiful. Look at the little ferrite ring they've got around those. They've cable tied those together, and of course your earth is, it's going from, the main board down there. It's all crimped properly and going over to the case. Oh, it's beautiful. Nice, neatly wired. Ah, it's just gorgeous. Genuine Omron relay for all you Omron fanboys. There's a lot of them out there. And why they've got that on the mains board, what are they doing? And they've got 2 wires going over to the power supply section. I'm not sure what's doing there. I mean, we've got the big clunking mechanical power switch here. So it's not like a soft power switch. Nice attention to detail on the interface board too. Look at that. They've got the ribbon cable, got a little ferrite around that, and that's going over to your front panel. Isn't that neat? Oh, bit of flat flex. And it's really interesting how they've done this. I mean, check out how much room they've got in here. You could swing a Schrodinger's cat in here. It's unbelievable. Like here's your front panel board over here. Okay, there's your, they've got ceramic output caps. That's interesting. I would have, I'm sure they're like, you know, the proper termination ones, so they're not going to catch fire. I've done a whole video on that. Here's your wiring coming over from the front. They've even matched the blue. Look at that, isn't that gorgeous? And then here's your wiring buggering off right to your back terminal. You've got your power wires plus your sense lines as well. Looks like we've got an Atmel microcontroller down there handling all that business. What's that micro? I can't read that on the screen. Controlling all the business on there. Got some local regulation here. And another Omron relay to do the switching. And you'll notice that this channel, 5 amp rated, this beast over here is just flapping around in the breeze. But this one up here has an angled heatsink going back over to our main heatsink. They've got a sill pad on there to isolate that. So this is the 10 amp channel. That's not going to be the output transistor. Maybe that's the over voltage clamp, perhaps, because it's right near the output like that. Oh, actually, that's a single jobby. You can see there's some extra holes there. And this one, dual. There you go for the 10 amp one. So we've got them back to back there. I've got to read a part number off that. Aha, that's actually the output current sense resistor. That's a PBH-R100. So R100 means 0.1 R or 0.1 ohms. So that's 100 milliohm output shunt resistor. Here's the data sheet for that. And of course, they needed 2 of those. They're probably, I don't know, whacking those in parallel for the 10 amp job. So that makes sense. It's a 3-watt precision power resistor. Not necessarily a fan of these big tall caps here just flapping around in the breeze. I would have like gunked those together. I would have liked to have seen that. Anyway, got some extra little power trannies down in there by the looks of it. Maybe they're like a part of a Darlington pair for the main power transistor. I don't know. I'm just guessing there, but oh, what's that linear tech jobby? What is that? And Nichicon, of course, spared no expense.
Really spectacular, spared no expense.
And once again, the 10 amp module is actually significantly different. Look at this big choke here, and compared to this one over here on the 5 amp, they look like a very, very similar configuration. They've both got these 3 caps here, these 2 caps in here, but very different little choke up here. Little, huge. Look at them. But they've got 2 main filter caps are the same on both. And as for the bottom of the board, there's your big ass bridge rectifier. Some smaller little bridge rectifiers in there by the looks of it. So they're just tapping off some multiple stuff. Oh, it looks like we've got some surface mount fusies in there. Oh, look at that MELF resistor. They had to have 1 MELF resistor on the whole thing, didn't they? Yes, thank you very much. You know I love my MELF resistors. There, our output power transistors. Like, it just seems out of whack. There's our output power transistors, and there's our big ass bridge rectifier on the input. Unbelievable. Anyway, that's a big ass surface mount inductor, and looks like we've got a couple of little opto couplers there on the output, and that's about all she wrote. There's our reverse diode protection on the output, and not much else doing on the bottom. Oh, they're actually not the same. I thought they'd be identical. And there's your high voltage noise suppression cap going to mains earth, because this screw, of course, goes like this little isolated bit of copper here, which isn't connected to anything else, but it's connected to that screw, which is connected through to the heatsink, which is, of course, connected through to your chassis and hence your mains earth. But, of course, these are galvanically isolated outputs, so this is your actual output ground part of your circuit from your bridge rectifier going through to your output. But this one's interesting because they've got 3 parallel pads here. They've populated 1, and of course you wouldn't really need to populate more than 1, but why you'd have 3 pads as part of your layout, I don't know. That position's not really going to matter. Bueller. So that looks like a real robust and professional design, as you'd expect. And of course, like on a real high-cost professional supply like this, you know, you're going to get like your noise performance, your common mode chokes, and, you know, everything to prevent like mains noise and stuff getting through. You know, the big EPCOS filter up here is just, you know, like really spared no expense in getting that down. And that's what you're paying for in a, you know, a real top brand professional power supply, as opposed to some one hung low eBay cheapie or some, you know, built down to a price kind of power supply. So I'm just thoroughly impressed by that. That is just some nice, brilliant design and construction. Oh, sorry, I thought these were the output caps, but they're not. They're also going down to noise suppression, down to mains, earth down there. That is your tiny amount of output capacitance. One little ceramic jobby. Yes, I do hope that is a, you know, one with flex terminations on the end, but of course this board's not going to flex. But still, you know, I probably would have put 2 in series, maybe, just to gild the lily. But anyway, you don't want a large amount of output capacitance, because in constant current mode, if you have too large output capacitance, it can effectively override your constant current mode and then dump the energy in the capacitor into your poor little device under test, and, well, your current limit didn't do its job because there was all that reservoir capacitance on the output. So you really want a minimum amount of output capacitance, just enough to keep your control loop stable, and that's it, no more. So your cheapest power supplies might have, you know, a large amount of output capacitance just to make the control loop more stable. They just, you know, whack it in until it's stable, and Bob's your uncle. Oh, but of course your earth filtering caps in here, they're also going to be basically 2 capacitors in series between your output there, except that the center tap is going to earth. But it is effectively output capacitance too. And there's our front panel micro. For that, that'd be running all the, effectively the OS for this thing. And of course, we saw the individual microcontroller on the individual output boards, but this would be running like the display, the interface, the Ethernet, and all the, you know, the USB control and all that sort of jazz. So there's not much else on that front panel board. The paranoid in me, though, can't help but think that screw's a little bit high. If you look at that, it is below the surface of that, but there's nothing inside the case, like there's no insulating sheet inside the case to prevent, and there is a bit of bow when you put this case on. You can actually press it down a little bit, and in theory, you could actually press it down onto that bolt, and you'd have your shorted turn from the top to the bottom. So, should I give it a go? Should I poke the top of this? 3 amps, look at that. 3.6 amps. Don't want to short your turnout. Don't. All right, check this out. I'll put the case back on. Hopefully you'll be able to hear this when I press on it. See? It bottoms out. So if you actually had, if you sat something on the top, that would, you know, like, I don't know, another instrument or something. I don't know, your coffee mug wouldn't do it, but, you know, if you put something, it requires a fair bit of force, but there's like, you know, and maybe 3 or 4 millimeters of travel, but it does actually hit the bottom of that. So in theory, but it's probably protected by the coating on this. It's not bare metal on the back, so they got coating. So it wouldn't short out, but like if you had a sharp bolt on there that could pierce through, that's possible. I'm nitpicking, but I just noticed that. Now for the NGE 100, or it's the 103, I think. Warranty expires if broken. Well, bugger that. It's not even a screw under it. So that's the back cover. How does that come off? I got 2 of the screws out. What's going on? Okay, that was... Oh, yep, it's upside down. Whoa, there we go. Look at that. We're in like Flint. There's the bottom part. Oh, that's... Like, why? 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 do you have a very neatly laid and gunked down wire. That is a beautiful mod, but I can't help but think that's intentional. I mean, what? I don't know. And they've done this, well, this one is the, looks like that. That's going to your mains, that's going to your chassis, mains earth, and that's going buggering off under there. That's your USB port. Wow. Are they serious about a low impedance earth path to the USB port? Very uninteresting on the top. So we're going to have to get in there and have a squiz. But once again, a really big ass toroidal transformer in there somewhere. And well, somebody had fun with their wiring sleeves here. Wow. Okay. They really didn't maybe want any sharp burrs or anything to cut through the wires, and it looks like they're all cable tied through there. Wow. Okay, so what we have here, 3 screws on either side, it looks like is going to let you pop out this module. Presumably with all the... I actually think it's got to tilt out this way, so maybe I need to put it like that, because you've got the heavy toroidal transformer at the front here. Wow, this is really some compact system engineering. Oh, I'll get back to you. I feel like I've got to be a contortionist to get this out. Maybe I can get down there and pull the... No, they're all the connectors in there are celastic. You can't see that, but you will in a minute. I'm going to assume that this sort of swings out like this, but I can't... Hang on. Oh, I think I got it. Something went crack. Oh, yeah, no, I got to get these cables out here first before that'll flip out. Ha! I have conquered it. Yeah, look, I had to take out the fan, had to systematically take out this cable over here, then the fan, then this one as you opened it up. But look at that. Isn't that just, that is just fantastic system design. How the compact nature of how they leave all this space in here for this big ass toroidal transformer. Once again, I don't think we have an issue there. That bolt's not going to be a problem. But soon on fan, for those playing along at home, you'd like to see their fan brands. Oh, sorry. I think I shot all that with manual focus on. Oh, sorry if that was all out of focus. We're back in focus now. And beautiful. And we can see our separate channels on the PCB. It's one big ass PCB, but you can physically see the galvanic isolation on between all the channels. And of course, they're all going to be identical because the power and performance on this model, I believe, is all identical. Got the big ass cats, so have a look at those in a minute. Surface mount heatsink on there. So not much doing. And wiring is just, looks like it's just soldered flat onto the PCB. That's interesting. Yeah, that's a really interesting arrangement. Look at that. And of course, they've got a sense line coming back, which is, nice. You'd expect this in a professional supply. So it's reading the voltage directly at the output terminal. Of course, this doesn't have any external sense terminal, either on the front or the rear, but they're actually making sure that they read back the exact value from that. But look, they just tin those leads and tap them down to the pads. That's fine. I mean, it's neat and tidy. It's simple. I just sort of expected connectors, but there's no reason you can't do it like that. It's perfectly fine. Once again, we've got our mains, our output to ground mains suppression cap there. We've got that on each channel, and looks like there's no additional output capacitance on the output terminals. All of your output capacitance is contained here, and they got different values in parallel. Look, itty bitty teeny weeny, and a 0805, and then a 1206, and then a couple more like that. Wow, they're really serious about their different types of output caps. That would be our reverse diode protection there. They're our current sense output resistors. They'd be They'd be doing your Kelvin connection to that, tapping that off. Oh, more current sense resistors over there. And as I said, the output, hang on, this has to be a switching supply, because that heatsink, that little piddly surface mount heatsink, I like that, that is not enough for a linear supply. So, and neither is that. They're a fan of their gold dots, aren't they? Love it. Once again, we've got Nichicon main caps in here. There's our bridge rectifiers on the input. Yeah, so I think what we've got here is this is most likely the output linear regulator, but it's got a tracking switching pre-regulator here. These are 80 volt jobs, and the full wave bridge rectifier from the mains creates a DC, and we've just got a DC to DC converter, which then tracks, only like a volt above, or half a volt above, so that regardless of your output voltage, it's going to be super efficient. So you only need a tiny heatsink on your secondary output linear regulator. But of course, using the output linear regulator, you get much lower noise than just a direct switching output power supply. And sure enough, if you have a look down in there, that's a NCP1034, which is a synchronous buck converter. There you go. So, yep, they're just bucking that down to, as I said, probably like, a volt at most above the output pre-regulator, and it's always tracking that. So, of course, this is getting rid of most of your noise. They'd specially designed, usually like a lot of secondary, linear regulators aren't very good. I've done a video on this somewhere, of like noise just, a lot of the noise passes through. So they'd be really looking for the power supply rejection on the design of the secondary output regulator there. So this is interesting. Here's our mains power switch here on the front. It is a proper clunkin' power switch. That comes from the IEC connector at the back. No worries, it's got a nice looking input common mode choke and all the requisite protections. Then we've got some sort of little isolated secondary power supply here. You can see it's the AC tap from the transformer, bridge rectifier, and that looks like maybe a little switching converter or something there. Little fuse jobby down in there. This is actually the fan controller here. And then this is all your primary taps for your transformer, which is connected over here at the back of your voltage selection switch over here. So how does the mains get from here, bypassing all this, over to here? You might think it's on the bottom, and you'd be right, but that's what this bypass wire here does. It takes that mains over there over to your primary transformer. So what, they run out of routing room to snake it over? Because you can see the other trace here going actually on the bottom of that, around like that, just avoiding these two sections here. So PCB designer went, oh geez, what are you doing to me? Maybe it was like a later edition or something. Maybe they just got to the end of the layout, and went, oh yeah, forgot all about these. We'll shove them in here, but we don't have the electrical clearance. No like slots routed or anything like that, which is fine, if you've got the creepage distance across here. Creepage is across board, and clearance is across an air gap. So I'm sure I've mentioned that in many videos. Anyway, yeah, there's no routed slots to get any clearance instead of creepage in there, but they obviously decided, oops, let's just run an extra wire. Okay, there's nothing wrong with that. It's done neat and tidy anyway. Nice big board. And these are all your secondary outputs of the transformer going into smaller bridge rectifiers. They've got multiple, well, 2 per channel. There's another bigger one, I'm sure, up there, bigger bridge rectifiers. So 3 separate rectifiers there supplying various whatnots. And as I said, electrically isolated on each channel. You can physically see the light shining through there. If I get my torch, there you go. Look at that. Beautiful. Galvanically isolated between each channel. You might notice though, this ground up here, once again, these are these AC caps. A lot of via stitching in there, and they've joined these together, all three, snake up there. That's where it goes back to your chassis. There's our front panel board down there. There's our Wi-Fi thing, and looks like we've got a big ass Atmel processor down in there that's running everything you could possibly imagine. And there's some memory and DRAM and flash and all that. So yeah, it's probably running some Linuxy thing, I'm sure. Ooh, look at the shielding on the ribbon cable going over there. Look at the scholastic gunk. Somebody had fun. And you might be asking, or you should be asking, Dave, if they're all galvanically isolated like this, how do they actually control each channel going over? Well, I'm glad you asked. So all the control signals come over here for all the 3 different channels, but you'll notice down in here, boom, boom, and boom, down in there, that is your serial isolator. They're using, like, maybe is it one of those analog devices, ADAM chips or something like that. Anyway, just like, you know, serial. They don't need anything like high speed really going over to each channel, but that's how they electrically isolate the data going over to each channel. So once again, I'm thoroughly impressed by the design, construction, and the engineering. Oh, just wanted to show you that there's those cable ties, and look, oh, look at all the braid for each wire. It's just beautiful, so that it, you know, it goes over the edge and doesn't nick it. Fantastic. Because you've got to assemble this like this, and the wires can rub over the, you know, potential. They aren't sharp, but they could, you know, they could potentially be a burr there or something like that. Anyway, beautiful, like, fit to envelope design. They've tried to keep this as compact as possible, unlike the previous ones we saw that were, you know, like, there's a fair bit of voidy space inside there, and there's nothing wrong with that, but this is obviously for a different market. It's designed for a more compact benchtop unit, and a very impressive design and construction. So this is the difference. And like, if you look at this, like, which is $1,000 class power supply, compared to like the Rigol, which is what, $400 or something, you know, like half that, $500 supply. Yeah, this one's, you know, it's better engineered, no doubt about it, and it's going to be, you know, much more efficient and lower noise and everything else. So yeah, it's just beautiful. A lot of work's gone into that. So hats off to the designers at Rohde Schwarz. Rohde Schwarz don't make crap stuff. They, you know, you pay your money and you get your top quality. It's just beautiful. Ooh, this one isn't self-tappers. And the bigger one, we'll have a quick look inside, but I expect it to be very, very similar to the other one, except, well, that's not a transformer. That's a transformer. Oh, I do believe you'll find that this is near identical to the other one, except, you know, we've got the big dual current sense resistor here going back. It's like virtually an identical layout, because these are all 10 amp outputs. So yeah, really identical across the series. The input switch-in reg, the input switch-in pre-regulator looks exactly the same. So yeah, nothing much to see except look at the badass transformer. Oh, I just can't get over that. And didn't the other one have a flat? And this one just mounted vertically like that, and the rod going through. It's just fantastic. Look at it. Bigger and beefier. And of course, those front panel boards down in there, they're going to be slightly different because the configurations are different in terms of the sense wires. They're just like grouped in 4, 2 above the other, instead of horizontal like we got on the 2020 there. Don't know how to convey the size of that transformer, but like, there's my hand. Look at the size of that, and like, it's like, it way more just that transformer alone than the entire NGE 100 supply here. That's just it's nuts.